Welcome to our Generation AI podcast, where we demystify artificial intelligence in the world of higher education. I am, of course, the lovely, awesome, amazing JC Bonilla, joined by my insightful, okay co-host, Ardis. Kadiu. What's up?
Damn, wow. Hey, I mean, I haven't been giving you the praise enough, so now you have to do it yourself. Is that what's happening here?
That's what's happening. We're doing a role reversal. I give you all these flowers and end up with bite the book. So, hey, gotta sing my own praises.
I see. Well, that's good.
This is what happens. This is what happens, everybody, right? In marriage and partnerships, right? As you become deeper, and Ardis and I have been working for a long time, then you have to praise yourself, right? So Ardis, my marital spouse and partner, is not giving me the roses.
I take you for granted, JC.
What's up, man? How you doing?
Doing great. We are in the middle of summer here in Raleigh. There's a lot of rain that's been happening, so it's been very rainy. But other than that, things have been really good. There's a lot of stuff happening in the AI world, but today we are hoping to talk a little bit about one of the, I would say, computer mishaps that happened and paralyzed the world.
I heard the best example of what happened via Scott Galloway. He said, what happened in July 29, 24 is what we expected for Y2K to be. It just basically didn't happen on January 1st, 2000. It happened almost 24 years later. That a computer glitch halted the world, right? So basically about 7 days from this recording, the world came to a stop, but not the entire world. A subset of the world, right? The Microsoft world.
The Microsoft world, and specifically those enterprises or those users who are using a specific security software called CrowdStrike.
So it is the reason why we want to unpack this, as we said, we need to have an episode around cybersecurity, but obviously we want to bring the AI angle. And I think what we want to do in this conversation, everybody, it's do two acts. As you know, Ardis and I are awesome nerds. Specifically, I worked a lot on chip design. Ardis is a computer engineer. So we understand what's happening behind the scenes. But the world of cybersecurity and AI really complement each other. And there's a weaving narrative that emerges from this. And I think that's going to be Act 2, as we walk you through what happened. So it's very clear in how basically this takes us to a computer architecture decision that stems from the 80s, right? To, I know, right? To what is happening today in 2024 vibes or cybersecurity, AI coming together.
And enterprise deployments, yeah. So we should look at this from an angle of enterprise as well, right? Our schools today and a lot of the higher education today are centrally managed, right? So it's really hard to bring your own device, or maybe sometimes you do, but there's the IT team that's has a stronghold, and most of those systems are Windows operated, and they're kind of centrally managed. So we call those endpoints, right? These different devices that are everywhere and all over the world. This, from airlines to banks to television stations, like all of these different enterprises and all of these different companies, they manage a large inventory and large fleets of computers or devices that can be deployed at anywhere, right, throughout the enterprise and geographically everywhere. And they need remote management. They need, this centralized systems in order to manage them and control them and do all of these different things. So when we talk about the whole world hold it to a stop, the effect was much bigger because it affected enterprises. They were critical in nature, and it affected those systems, right? So it did not affect people who were at home with their Windows laptop, because it was not a Windows issue. It was the CrowdStrike security software, which a large enterprises use.
Correct. So there, as we unpack what has happened, for those of you who are not familiar, we're going to be talking about 4 players here. Enterprise, right, players who look like airports and travel agency, banks, hospitals, right? A university. Number 2, we're talking about CrowdStrike, a service provider in terms of cybersecurity that uses Microsoft systems, Apple systems, and many other systems to deploy their services. Microsoft, which in this case, they've they have an architectural decision stemming from back in the day. We'll talk about that. And they got the worst out of this update that CrowdStrike does. And of course, the fourth, which is basically the victims of this, the consumers, right? And then some of the horror stories that are happening. So let's go back to player number 2, Microsoft. Ardis,
Mm-hmm.
the good old blue screen, right? What has happened here is that if we remember some of the decisions in the Bill Gates, Steve Jobs, closed systems, open systems that stems from back in the day, is that Microsoft allows partners to come in and be part of their booting sequence, if you will, right? Whereas Apple has it closed. And this is basically one of the differences between Apple and Microsoft. What does that mean? That when you are developing technology for a Microsoft, you can go into the routine that basically is domino zero of all the things that needs to happen, and your code can be running there. Microsoft has allowed that to happen, and it's worked really well for, 30, 40 decades, right? Apple doesn't allow you to do that. So when this update comes from CrowdStrike, that's where basically the cost in a more simplistic way starts stemming. So basically it doesn't allow the computational power, the sequence, even the fixes to come along, because basically it's like, I have a problem, but it happened on domino zero out of all the things that need to happen, right?
Yeah, no, that's absolutely true. So, I mean, that's where it stemmed, but do you have any more details around exactly what happened at that point? So let's say your machine boots up, you have a security piece of software that is running on your machine, and it needs to run as soon as the machine is booted up. And that's the client, the CrowdStrike piece of software. But how did this happen, right? Like, why did the blue screen of death happen?
As far as I understand it, and you could probably give us a more technical depth, this is more your domain. As far as I understand it, right, what CrowdStrike does is that it pushes an update of basically malware and things like that prior to this. And this is basically, think about it when you boot. These are the 17 threats that maybe happen on the booting sequence, and they run it at that stage. That update crashes. And what is happening in that crash, system malware from CrowdStrike crashes, doesn't allow the Microsoft system to continue its routine. So you end up with this basically blue screen of death that basically looks like nothing can proceed. And good old Control Alt Delete, remember that? The idea of you boot sends you back to that place. So there's basically, in computer systems, we'll call them the infinite loop, right? And you just basically end up in this, you cannot exit that, and no force, reboot, or even soft resets or hard resets can get you out of it.
Yeah. Yeah, that's a very good, easy explanation of it. Of course, as a programmer, as somebody who's done programming, memory management is one of those things that was really difficult with older programming languages. And going back to my CS classes here, one of the big issues was memory management and kind of what we call null pointers. Basically, it's like, hey, your program is pointing somewhere where it doesn't exist. Or something doesn't exist, and that's not caught. And as part of the security updates or as part of the QA process, and now when you deploy that in the system, it just says, oh, the system is like, well, you're not supposed to be pointing here. There's nothing here for you. We're going to treat you as, I'm going to kill you. I'm going to kill this program. So essentially, that's where the loop happened, right? So the package that was deployed was that. Now, I want to go back and kind of talk a little bit about, so there's a AI angle to this, and the AI angle is around security software. So security software has gotten more and more sophisticated over time, right? So the AI angle here, when we look at CrowdStrike, we call the systems, if you're thinking about them, like you would call them more kind of the endpoint systems, right? So you're thinking about the systems as.
And Ardis, before we go into the AI angle, I just want to remind everybody that with this impact, just a color of how it got manifested. So we spoke about airlines being disrupted, hospital credit card systems. There were delays on the judicial system, because of schedules and courts. Government was affected. So even 911 call services, because to your earlier point, enterprise deployment, right, has this kind of, system of licenses, and it had literally a worldwide effect. Duration, it was at its peak for about half a day. But the interesting thing is that there's an aftermath that we are experiencing. There's still luggage in LaGuardia and many other airports that have not been picked up because it got sent or it never got sent, and they're trying to figure out how to do the tagging system. There continues to be an interesting tale. And of course, the companies being impacted in stock and all this type of things that are at place. But Ardis, let's switch to the AI angle here. The idea of there is a connection of these problems in computer architecture to, in 2024, the AI angle, enterprises, and I guess null points become a reality. So
Yeah, yeah. So the AI angle here is that CrowdStrike, they're calling this is a what's called an endpoint protection and malware detection types of software. So there is something that gets installed to that machine, and it uses a lot of different components, things like signature-based detection to figure out different kind of security threats that are coming in, right? And basically, you have AI algorithms that continuously monitor these endpoints internally to those machines. And when we call endpoints, we're really talking about the actual physical machine, right? Because you call it an endpoint in security terms. But they're detecting activity for unusual behaviors that may indicate a compromise, including things like what we call zero-day exploits. Things like we don't have a signature for this type of malware, but because of its behavior, it's acting like something. So it's the output. It's the black boxiness. So you're measuring the output and the behavior stuff, and that's where machine learning models can recognize some of that signature and those behaviors that are known malware strains, and they can kind of say, oh, I can also help detect sophisticated or what's called mutated forms of malware, right? So you don't have to have a library of all this malware, but you're essentially using AI and machine learning to kind of figure out, okay, based on all the behavior, is this signature, probabilistically malware or not, or is this compromised or not? So a lot of AI algorithms are going into that for security reasons. So that's the AI angle here, which is really amazing. And what CrowdStrike does is that they deploy, essentially think about it as like little mini models or little mini templates to the endpoints, and they are now updating in that way. So think about like having an AI model or like AI weights or whatever, and like you're giving it little updates and saying, okay, I'm gonna update your weights, I'm gonna update your signatures, and they call them templates. But one of those was broken when they deployed it, and that's kind of why we got to this point, right? But it's really, really interesting because we have like AI is playing a huge role in security today. And a lot of the most sophisticated security companies that are growing the fastest are basing a lot of their work around AI and AI detection for these larger systems, because you can't categorize on all of the different malware or code or anything like that, but you can see signatures of behavior.
Hey there, it's Mallory, Chief Strategist of Enrollify. Higher ed is facing a leadership crisis. The demands on today's college and university leaders are skyrocketing, and talent is leaving the industry at an unprecedented rate. New leaders like you are emerging, but no one is getting the proper training to be successful. Well, Enrollify is here to change that. Our new course, Lessons in Leadership, taught by Dr. Carrie Phillips, will prepare you to be a confident, empathetic, and effective leader. From systems thinking to adaptive leadership, building culture to handling difficult decisions, this comprehensive online course is perfect for new and aspiring leaders. Don't wait. The course starts September 9th, and for a lucky group of 26 students, we have the option to add interactive sessions with Dr. Phillips for personalized guidance. Visit Enrollify.org to learn more.
And Ardis, as you walk us through these steps, the first thing I'd like to summarize is that the intersection between AI and cybersecurity is at the idea of the complexity of these modern systems, right? And one of the things that AI allows us to do really, really well, and we should start leveraging this, is that no one can anticipate when things go bad, how bad they could be, right? And there's an aspect of either because these ideas of what we call synthetic data right now, when we're talking about, the power of AI and computational muscle to do really advanced simulations, because who thought that this was going to affect credit card systems or, judicial systems, right? The idea of what is the extent of failure, because if we have a single point of failure, what we're seeing is that that single point of failure had multiple manifestations. And understanding the complexity of the modern system is really, really important. At the same time, the complexity of the system needs to have a really important conversation about the human angle, right? We cannot just have, because it's so complex, we can have just one point of failure and brings it all together, right? So how we start thinking about not only testing, but the idea of redundant systems and AI systems that are dynamic to basically start, I want to use the word shifting the network, but that comes more from electrical engineering. But you know what I mean, right? This idea of understanding ways to do flow updates. One of the things I've liked, and I wonder if you can riff a little bit on this. You and Element sent updates to everybody, right? How does an update work? Do you say everyone's going to get it? Do you say only a subset of the population is going to get it? There's an ongoing joke that in the airline industry, right, everyone's affected. But if you fly, my gosh, not JetBlue, Southwest, you were not affected because, they're still...
They're using mainframe.
Yeah, they're still like in Windows 3.11, right? But to that point, right, you can detect the users that would not get the benefit. But what can you start doing in terms of breaking up an update in micro updates for basically system tolerance, and having AI to understand this is working well or rewind it? How does that work? And think about Element, where you guys are doing updates all the time. How would you use AI to break up an update of not?
So in this case, there was a lot of memes and a lot of meme cartoons and things like that kind of came up. And because this happened on a Friday, there was a lot of memes. It's like, all right, newbie came in and deployed some code to production and didn't even test it. So at the end of the day, I think this is not necessarily like it's a failure in an organization to actually do deeper quality assurance on the things that they're deploying, right? So that's the part that we're failing to miss here. So it could have been, hey, somebody was really tired, somebody didn't, bypassed all the automated checks, or the automated checks weren't in place. So those things are the first line of defense, the automation. And we have really, really good automation around test suites that we put together. But what you're saying is like, are you deploying this thing and then seeing if it's actually working in a production environment, right? And that's called end-to-end testing, right? So this end-to-end testing, that we do a lot of that, where essentially it's like we deploy the software and the test is looking for, it's opening up a browser and it's looking and saying, okay, is this thing loading? Is the app even loading? And if it's loading, then it's like you have other tests that you're running. It's like, okay, let's go through a routine of actually doing a specific task as if you were to click through these different screens. And so that runs every single time that we deploy code or that we deploy something to production, right? Because you need to run all those tests. But in this case, I'm not really sure how that got missed, or this production, testing got missed. And it becomes really difficult to check when you have a larger, more complex system, right? So it becomes a lot harder to check and test. So that's where, in a lot of cases, AI can kind of come into that testing environment and create essentially test scenarios. And AI is coming in. For example, for us, in some cases, you need to test a form, but you need to test that form. You test it with, like, a human person will test it with a real name, or automatically they'll enter real data in there. but you need to be a trained QA tester in order to put in fake data because we're not thinking it that way. But an AI system or an automated system can come in and say, you know what, I'm going to generate, 1,000 fake names, 1,000 fake, like I'm going to put in characters and I'm going to put in different lengths or whatever. And machines can do that really, really fast. So the newer test suites and environments, like we're using a lot of AI to generate the synthetic data to test these things out better. Now, I'm not talking about CrowdStrike specifically. That's how they're doing it. But going back to software testing, specifically around AI, it's playing a huge role in that side of it.
I think there's two really important angles to break up here. Actually, three angles. Number one, it's clearly that this podcast has slightly pivoted from AI cybersecurity to AI in software development, because really this is what we're talking about in a way. In the problem that we saw from
our last episode was similar. It's like, hey, let's use this large language models for some software development.
There's a bit of a pivot here, but to that end, Ardis, it is really clear that AI can help us create significant testing infrastructure that stresses our deployment of software to the next level, right? And then it's probably much better at looking at edge cases and the rigorous aspect of testing. So I think that's clear and you articulated really well. Let's go back to your earlier point. This is an enterprise aspect. So how is AI under the lens of software deployment kind of helping us with intelligent software systems, right? That my update is your update and it gets updated and all of a sudden, like, I'm a node. Is there something that you think you're seeing in terms of the current state? But, if Element belongs to your ecosystem university, right? So Element is cloud-based. So if it fails, it should not affect your SIS. But there's other things. If your SIS is, I don't know, it's being right now updated to security, that security update could affect your SIS. And guess what happens when the SIS fails? It would probably affect Element. So you start seeing, because Element needs those feeds. So you start looking at, there's dependencies, codependencies, but there's also software walls, and they're not bi-directional in that sense. So where do you see intelligent software systems coming into play with AI, if anything? Is it just monitoring that we get, advanced monitoring, this is failing and everyone knows and alerts? Is there anything else that could happen? What do you think?
You mean specifically where AI is helping out with the...
Yeah. How could AI help us prevent these issues that we saw last week? Sure, I get the testing point. But that this is a codependency. How say that I'm a university and then, my system was down, right? There could be at least one university that uses a Microsoft infrastructure, and because of SIS, it's in that level. So
we did have a bunch of clients that were down and they were dealing with this, by the way. So yeah.
How can AI help us prevent that besides testing? Is there anything else?
Well, in this case, it couldn't. So the AI couldn't prevent it, because like you're essentially giving access to a trusted third party to manage the security on your devices. That's the big part, is that you can't really recover from it, or you can't really do anything or prevent it even remotely, because it has access to that core data. Now, this goes back to access and security on enterprises and even our IT systems, like how locked down are they, who has access to what, and kind of what security procedures you're following. But at the end of the day, some of these security systems, like they need access to the deepest system level components in order to detect malware and in order to detect these things, because that's where they're going to be, right? You can't just have something that's running on the cloud that's monitoring a local machine without having a piece of software in that local machine that's telling it, hey, this is all the behavior that's happening, and reporting that back.
Is there an application, and this is where I'm trying to push your Ardis, and the first answer was like, no, it cannot be done. So here's another angle. There's a technique in finance that is called high frequency trading, right? That looks at a electric digital transaction, and it benefits from the nanoseconds. So can AI be fast enough, do you think, to detect that there's problems are taking place and just cut off the pipeline of updates. In my head, what is happening is that it starts sending updates to you, and also like it knows that it's something that's going on. So it affected JC. Why would I send it to Ardis? Is this a bad idea? Does this even make sense in software deployment at enterprise level?
Yeah, now we're talking about software deployment, architecture, and systems. So
Is the third pivot on this podcast?
third pivot. So do you do what's called a rolling update, for example? Like you're doing a rolling update where you're sending the update to a smaller percentage of nodes, and then you're seeing if that's working, and then you continue to kind of increase your deployment over and over and over. So that's called a rolling update.
We can assume Strikeforce did not do that, right? Because it got, yeah.
No, because the way these things work, JC, is that you don't push it down. You essentially, the local servers or the local machines, you don't know if they're going to be online or not. So it's a pull model. So essentially you put it somewhere, and then you put a timestamp on it and say, this is the most up to date. And then every time that the machine logs on, it checks with the endpoint and says, hey, do you have anything new for me? And I'm going to grab it. So everybody coming on at the same time, or whenever the machines came on, or whatever that happened, or time, like they just pulled all the stuff. And that's why you saw things failing, for example, in
Europe first. Yeah.
In certain parts of the world first, and then coming here, right? Because it was just the timing of when those things got pulled down.
But to my point, I mean, we should have seen it in Australia. And why did it replicate in this part of the world?
Because they didn't fix it. They didn't fix the endpoint thing. Because they didn't realize that was the issue or whatever. I don't know. I mean, that's what I'm assuming. It's like it took them some time to fix it. By that time, a lot of the systems all over the world had pulled that piece of code down, and preventable. Yeah.
Well, everybody, I'm really trying to push this angle here. There's going to be more AI for software development, cybersecurity, multi-node deployment of updates, the works. So, but it seems that my limited capabilities are taking me this far, and I cannot crack Ardis yet.
Is this your next thing? Getting into AI security?
Absolutely. Specifically, I'm going to try to figure out how to penetrate governments. That's definitely what I'm been looking for.
No, JC's, it's only kidding. So we're having a disclaimer now. This is only a joke. What's really interesting, JC, is that, for example, there is this company, Google has been on a buying spree in terms of security software. And one of the companies that they were going to buy, but kind of pulled out, was Wiz.io. And they basically we secure everything you build and run in the cloud. So it's like cloud security. So, like you have your local machines, but then you also have a lot of servers in the cloud that are doing all these different things. And Wiz has those products that does everything from vulnerability management to scanning to, there's a lot of acronyms on their website that I don't even know what they mean or what they do necessarily, or what kind of bucketed security components they have. But they do code security, supply chain security, all of these different things. And they were going to buy them for, it was billions of dollars. Their largest acquisition.
23 billion, if I'm not mistaken. Yeah.
23 billion. Yeah. $23 billion. And this company has been around for
like 2 years, right?
How long? 3 years, right? 3 years, 4 years, something like that. It's crazy. It's incredible, right?
The artist, so you asked me, that's what I'm going to be doing. That's what I want to do now, right?
Okay. Security.
Right. I know. God. But sorry, that's a joke.
Forget marketing. This marketing thing is not getting us anywhere.
And maybe as we try to conclude the episode here, one of the things that is emerging from this is, in this interconnected world, there's gigantic players. So one of the things that it would be fascinating if really Google has this muscle, right? And also like they own security and whatnot. How does that benefit us or not as it relates to system of failure, right? Because in software development, it's not if it's going to fail, right? It's when it's going to fail, because, it's impossible to control for that, and how vulnerable things are when they become massive and too big, right? So had CrowdSource not been such a successful company with worldwide applications.
CrowdStrike.
What did I say?
It's okay, man. You're like, You butcher the names all the time, but it's okay. I think that's part of the
That's part of the brand. That's part of the
part
brand.
of the brand of
Gotcha.
the exactly.
All right. So, Crowd Mama, it wasn't that big if the impact wouldn't be felt globally. So the aspect of the size and impact of these organizations and how the technology dependence is so massive, right? And how we also benefit from it, because had OpenAI now reached this scale that is global, right? Computational deployment that is needed would not have advanced. So there's a really interplay that AI needs of scale, massive for us to benefit from. And at the same time, it's a give and take. So what do you think of that as a wrap up, Ardis?
Well, you kind of maybe set up our episode about open source models and AI with Llama 3.1 being released. The way that you combat that is through open source, by having more eyes on it and by having more ability to kind of inspect what's happening underneath.
Gotcha. Well, there you have it. Thank you, everybody, for joining us today. I'll walk down computer architecture, computer software, computer deployment, software releases, AI, and of course, a bit of butchering of names. Ardis, you want to sign us off?
Till next time, everybody, rate and review our episode. 5 stars as always. Have a wonderful day. Bye-bye.
Bye, everybody.
Generation AI is part of the Enrollify podcast network. If you like this podcast, chances are you're going to like other Enrollify shows too. Our podcast network is growing weekly, and we've got a wide range of marketing, enrollment, and higher ed technology shows that are jam-packed with stories, ideas, and frameworks, all designed to empower you to be a better higher ed professional. Our shows help higher ed leaders and professionals like you find their next big idea. They feature a selection of the industry's best as your hosts, like Jamie Hunt, Seth Odell, Jenny Lee Fowler, Brian Gross, and many of your favorite leaders in higher ed. Enrollify is made possible by Element 451, the next generation AI student engagement platform that's helping institutions all over the country create meaningful, personalized, and engaging connections with their prospects and students. Learn more at element451.com.